Breaking news. Terrifying messages from the space. NASA has made a jaw-dropping decision to shut down an almost 40-year-old Intrepid spacecraft after receiving these terrifying messages. This explorer has traveled through space for more than 40 years, gathering priceless information and sending it back to Earth. But let's dive into the reasons that lead to this decision. Voyager 1 has been relentlessly traveling farther and faster than any other spacecraft in human history for more than 44 years. After passing through Jupiter, Saturn, Uranus, and Neptune on its way there, it now finds itself in the enigmatic region of interstellar space. The Hubble probe has returned priceless information and enthralling photographs that have improved our comprehension of the immense cosmos that surrounds us. NASA made a difficult decision regarding resource allocations, but what terrifying messages did Voyager 1 receive, leading NASA to shut it down? Is this the end of Voyager 1? Well, space fans should not worry though, as NASA is not completely ending the Voyager mission. Instead, they have strategically decided to put several of the spacecraft's equipment into temporary retirement. Why? It all comes down to preserving the life of this extraordinary explorer. Because of the 4 watts per year power loss of these brave probes, NASA's decision-makers face a serious obstacle. They want to extend Voyager 1's mission for several more years, steadily cruising through space until the astonishing year 2030. By giving priority to power distribution to crucial instruments, NASA is working to extract every last bit of information from this tough spacecraft in a race against time and diminishing power supply. Voyager 1 is powered by a radioisotope thermoelectric generator, or RTG, which turns the heat from the radioactive isotope's natural disintegration into electricity. This generator is one of the key variables in NASA's decision-making process. As the power source runs out, the spacecraft's instruments must be shut off one by one because the RTG's power output degrades over time. In its epic voyage through the vast expanses of space, Voyager 1 embarked on a new chapter as it ventured further from the nurturing embrace of our sun. In a pivotal moment in 2020, NASA made an important announcement. The CRS heating system of the spacecraft was gracefully retired. This decision, driven by the need to conserve power, recognized that Voyager 1 had already surpassed its anticipated lifespan by several years. The wealth of data collected by the CRS on the intensity and distribution of cosmic rays fulfilled its scientific purpose. Furthermore, NASA had to grapple with the limitations of bandwidth, considering the challenges posed by transmitting data from Voyager 1 back to our home planet. As Voyager 1 ventures into the depths of the cosmic abyss, the vastness of space poses unique challenges for NASA in capturing and transmitting its precious data back to Earth. With a modest 23-watt transmitter, the spacecraft's signal gradually weakens on its incredible journey. However, NASA's ingenious deep space network of antennas and radio dishes works tirelessly to receive this invaluable stream of information. To ensure optimal data transmission, NASA has devised a strategic priority list for Voyager 1's instruments. This list is carefully crafted, taking into account the scientific value of the data and the urgency of the research at hand. A remarkable instrument, the magnetometer, which unravels the mysteries of magnetic fields in space, holds a place of high priority. While NASA remains dedicated to keeping Voyager 1 fully operational, navigating the farthest reaches of our solar system requires difficult decisions. Yet, these decisions bear great significance as they provide scientists with vital insights into the intricate interplay between the solar wind and the enigmatic interstellar medium. It's important to note that NASA has not shut down Voyager 1. The spacecraft still transmits data to Earth, even after more than 44 years in space. However, NASA has had to make some tough decisions about allocating resources as Voyager 1 continues on its journey. One of the critical factors behind NASA's decision-making process is the limited power supply of the spacecraft. Voyager 1 is powered by a radioisotope thermoelectric generator, RTG, which converts the heat from the natural decay of radioactive isotopes into electricity. The power output of the RTG decreases over time, meaning that the spacecraft's instruments must be turned off one by one as the power supply dwindles. In 2020, NASA announced that it had turned off the Voyager 1's cosmic ray subsystem heating system, which measures the intensity and distribution of cosmic rays in space. This decision was made to conserve power as the spacecraft continued to travel further away from the sun. The CRS had already exceeded its expected lifespan by several years, and NASA determined that its collected data was sufficient for scientific research. NASA must also consider the limited bandwidth for transmitting data from Voyager 1 back to Earth. The spacecraft uses a 23-watt transmitter to send its data, which is then received by NASA's deep space network of antennas and radio dishes. Besides that, the signal weakens as it travels through the vast expanse of space, meaning that only a limited amount of data can be transmitted at any given time. NASA has implemented a priority list of Voyager 1's instruments to optimize data transmission, determining which data should be transmitted back to Earth first. This list is based on the scientific value of the data and the urgency of the research. Data from Voyager 1's magnetometer instrument, which measures magnetic fields in space, is a high priority because it can help scientists better understand the interactions between the solar wind and interstellar medium. So while NASA has kept Voyager 1 open, the agency has had to make difficult decisions about managing the spacecraft as it continues to explore the outer reaches of our solar system. What medium does Voyager 1 use to convey the message? Listen to this. The Deep Space Network, a network of antennas in California, Spain, and Australia, is used by Voyager 1 to communicate with Earth. The antennas are made to pick up the flimsy signals Voyager 1 and other deep space missions transmit. A transmitter, a high-gain antenna, and a low-gain antenna are all part of Voyager 1's communication system. A low-gain antenna is utilized for close-range communication, and a high-gain antenna is used for long-range communication. The data must be returned to Earth by the transmitter. Voyager 1 must contact the DSN antennas to send data back to Earth. The antennas must be positioned correctly and capable of picking up the weak signals Voyager 1 transmits. Once the connection is established, Voyager 1 sends its data to Earth using a radio frequency signal. The signal is transmitted at a frequency of 8.4 gigahertz, which is in the X-band of the radio spectrum. The data sent by Voyager 1 is encoded in a digital format using a technique called pulse code modulation. PCM is a method of digitally representing analog signals such as images and sound by sampling the passwords at regular intervals and converting them into binary numbers. The data is then transmitted to Earth in packets containing a small portion. The packages are sent using the Consultative Committee for Space Data Systems Protocol, a standardized protocol used for deep space communication. Packets are sent at a rate of 160 bits per second, which is incredibly slow compared to modern communication systems. This is because the signal sent by Voyager 1 is feeble by the time it reaches Earth, and the DSN antennas must be able to receive even the weakest alerts. Once the DSN antennas receive the data, it is processed and stored on Earth. The data is then analyzed by scientists who use it to learn more about the outer solar system and beyond. Data is received in a digital format and must be carefully pre-processed to ensure that it is free of any noise or interference that may have been picked up during the transmission before scientists can begin the process of analyzing the vast and complex sea of information. After the data has been cleaned and organized, it is visualized using specialized software tools. This is where the raw numbers start to take on a life of their own, because the scientists can see patterns and trends that might not be immediately apparent from the data itself. This is an important step because any errors or inconsistencies in the data could lead to inaccurate conclusions. As they delve further into the data, the scientists start to detect small changes and abnormalities that hint at the unobserved workings of the universe. They can zoom in and out, modify the size, and analyze the data in ways that were previously inconceivable. Besides these and other strange discoveries made by Voyager 1, one thing is certain: our solar system and beyond are full of surprises and interesting events. The two probes were launched in 1977 and have kept pushing the limits of space research ever since. The distance these probes have traveled from the planet Earth, further than anything ever made by humans, cannot be overstated. As a result, these explorers will probably continue to retain the record for the farthest human-made item for many years, if not a century. According to the Scientific American story, the decision to reduce power to a minimum was taken to extend the probe's lives for a few more years, with a soft cutoff date of 2030. Ralph McNutt, a physicist at the Applied Physics Laboratory at Johns Hopkins University, remarked, "We've done 10 times the warranty on the dang things. For the time being, we must put up with the uncomfortable stillness and hold out hope that someday, somewhere, the truth behind Voyager 1's stoppage will be revealed